My name is Karen Bruner. I'm the tech evangelist at StackRox. We do security software for Kubernetes clusters. This talk is called Evaluating the Top 3 Kubernetes Providers. That's not actually my title. I forgot to update the slide. These are the top 3 hosted cloud versions. So first off, I've given you my name. I was an SRE DevOps engineer for a long time. I'm a totally sane cat lady. And I have a Twitter handle, which I've had for a month after avoiding Twitter for a very, very long time. Okay. So we're going to talk about Amazon's Elastic Kubernetes Service versus Azure's Kubernetes Service versus Google Kubernetes Engine. So first off, we'll start with version support matrix. This one I find this very interesting in kind of sad ways. So vanilla open source GitHub Kubernetes master, they just released version 1.18 to beta. It should be full release by the end of the month. We're kind of all over the place. All 3 providers have 1.14 as a default, but oddly enough, GKE was the last to make 1.14 their default version for new clusters. And they only did that a couple weeks ago.
This is current as of this week?
Yeah.
Okay, that's scary.
Yeah. Exactly. Yeah, I mean, yeah, you'd figure that Google, it's Kubernetes, it's Google, they're kind of behind. It's interesting that Azure, and this hasn't always been the case, but it's interesting also that Azure is actually the most up-to-date with the latest versions. They're still in preview and unsupported, but they're still up there. And the slightly scary thing is that Amazon is still at 1.14, and they released 1.14 for their platform in September, so it's been almost a full 6 months. And Kubernetes itself has a 3-month release cadence. They put out a new release every 3 months. So where's 1.15? Amazon? I don't know. They also don't do preview releases, so you can't even see if something's coming around the bend. We have no idea. They've been completely silent. So probably the first thing you're going to ask about a hosted managed Kubernetes, well, what's it like to do upgrades and maintenance? How much work am I actually going to have to do? Control plane upgrades. So this is what, the basic thing you'd think they manage. These are what correlate to the master nodes if you were running your own cluster. This is where the API, Kube API server sits. For your cluster, this is where the scheduler runs. This is where a lot of the critical admission and cloud controllers will run. EKS, all of this is manual. You have to initiate the control plane upgrade. AWS will actually upgrade the control plane, but all those add-ons, and by add-ons I'm talking even the container network interface, which runs on the nodes, which you're required to have. Core DNS, which you have distributed in cluster. The user has to manually upgrade all of these add-ons. You can automate it, but you're still responsible for the upgrade. AKS, user kicks off the control plane, but Azure will take care of everything. And in GKE, this is automatic. You can schedule these upgrades for a maintenance window, and because they should be 0 downtime, it should just automatically happen, and you don't have to worry about it. Node upgrades is similar. EKS, user initiates. When EKS launched, the node groups were kind of strange. You created an auto-scaling pool with certain requirements, and it just had to be able to run kubelet and be able to join the master of the cluster. But at reInvent in December, they introduced managed node groups, which are slightly more managed, but not significantly. It does ease the creation of the node group, and once you initiate the node group upgrade, it will drain and replace your nodes. But the trade-off is you lose a lot of configurability, a great deal of configurability. AKS user initiates. AKS will take care of all the upgrades for the nodes. And GKE, again, it is automatic. You just schedule a maintenance window, and it will upgrade your node pool for you. Node health monitoring, Amazon, Azure, neither of them have any node health monitoring. They'll monitor your VMs, but they're not aware of the kubelet or whether or not the kubelet is healthy, whether or not it's talking to the master successfully. Whereas GKE has automatic node repair. It will both detect issues and either repair them or replace the node. All automatic, all for you. That's on by default. So looking at the nodes, this is a grid of supported operating systems and images. EKS defaults to their Amazon Linux. You can also choose Ubuntu or even a custom AMI, and they have full Windows support, which is interesting because Kubernetes itself, it's still beta. If you're using a managed node group, which I mentioned before, you can only do Amazon Linux. Again, this is one of those examples where you lose configurability if you use the managed node group. You can still create a self-managed node group with any image you want, as long as, again, it can join the cluster. AKS, the only Linux version they support is Ubuntu, and they also have Windows Server in preview. GKE, they default to the container optimized operating system, but you can also choose Ubuntu, and they also have Windows support in beta. In Kubernetes, for vanilla Kubernetes, any compatible Linux, and again, Windows is in beta. Container runtimes, EKS uses Docker, AKS uses Docker Moby. I am like many people, I still don't understand exactly what the difference is, but AKS docs say Moby, so Moby. GKE uses Docker by default, but you can also opt to use Containerd for your container runtime. And vanilla Kubernetes supports Docker or any runtime which conforms to their container runtime interface. Technically, Docker does not conform to their container runtime interface. It actually uses Containerd as a shim. So even if you think you're not running Containerd, if you're running Docker, you're also running Containerd. All three have GPU support. You can install the NVIDIA device driver, and if you're on a system with GPUs. And all three support node pool auto-scaling. However, in EKS, again, you have to install the add-on and manage it yourself. This has really important security implications. The autoscaler, since it's creating VMs, you know, in EC2 it's creating instances, in Google and Azure it's creating VMs, it has to have cloud provider API permissions and credentials. So normally you would install this on the control plane where it's away from user workloads, where it's protected. But because you're required in Amazon to install it on your user nodes next to your user workloads, it's much more difficult to protect those credentials, especially even if you're very protective of the credentials. If any other workload on that node gets compromised and it compromises the node, you're out of luck. For the control plane, so EKS by default is highly available. You can't off-floor, and they will deploy to 3 availability zones in your region. AKS, the documentation does not say. It is strangely silent on this point, because you think if it were, you know, in most cases if you're looking at something, they're super happy to say, hey, you know, super highly available, we've got redundancy. They don't say anything, and there's also, I did some digging, I'm trying to, like, did I miss something? Googling, I found this one bug in one of their GitHub repos where it was not specifically about this, it was about the high availability of a related component. But since they had a Microsoft dev on there who was answering questions, somebody said, what about the control plane? Is that redundant? And in a list of like 3 questions, and the dev answered every other question, and yeah. So I can't say for certain, but I would infer that it is not a highly available control plane. GKE, you can either deploy a zonal cluster, which is just in one availability zone, or a regional. So zonal clusters, one availability zone, obviously not highly available. Regional, yes, it's highly available. There's a weird thing about regional clusters, though. It doesn't just make the control plane regional. If I create a node pool for that cluster, it's actually going to, and I say I want 3 nodes, it's actually going to put 3 nodes in each of the zones. So you end up with 9 nodes. So if you want a cluster with 3 nodes, then just tell it you want 1 node, and you'll end up with 3 nodes. So right now, I didn't put it in here, but there's a pricing. Currently, Amazon is the only one of these 3 providers that charges for the control plane, and it's 10 cents an hour. They just knocked it down from 20 cents, I think, last month. AKS doesn't charge anything. Google right now doesn't charge anything. They just announced that starting in June, they will start charging 10 cents for the control plane. 2 years ago, they actually did charge for the control plane, and they had different prices for zonal and regional, but it sounds like it's just going to be a flat 10% or 10 cents an hour. But right now, EKS is also the only one, even though they have these service level agreements, EKS is the only one that financially backs its SLA. But GKE says once they start charging again, they will also financially back their SLA. Oh, and pricing, well, just mentioning pricing. Other than the control plane, everything else, you're generally just using their, whatever, it's EC2 or their compute engine, or for AKS, their VM, their VMs. For the rest of your cluster, it's just the standard price for whatever virtual machines you're using, whatever storage you're using, whatever else. And the control plane, 10 cents an hour, I forget what it comes out to a month. So if you're running large clusters, it's going to be an insignificant part of your overall bill. However, it mostly impacts very small houses or hobbyists. GKE the control plane is not even part of the Amazon free tier, but Google is going to allow you 1 free zonal cluster per project once they start charging. So networking options. For Amazon, you're required to use their AWS VPC CNI. And this puts so what this does, they have, in EC2, you have elastic network interfaces. So these are the virtual network devices which attach to your instances and provide you network access. Well, they're putting the pods directly on the VPC network along with the nodes, by using elastic network interfaces. So this has some strange side effects. For one thing, they default to putting your pods on the same. So security groups, EC2 security groups apply at the ENI level. Even if you have multiple addresses, the elastic network interface, they all get the same security group membership. By default, the AWS VPC container network interface puts pods on the same interface as the node. So you cannot give different security group rules to your pods and nodes. This is bad. It's, your pods should not be able to directly address. You should be able to firewall and give them different rules. There is an option to customize the behavior, but it doesn't work with managed node groups, because you can't customize the image or its installation. So you have to use self-managed node groups. And it's not an insignificant amount of work either. It's actually a fair amount of upkeep. And you're also limited. Different EC2 instance types can support different numbers of interfaces and different counts of IP addresses per interface. So it's completely, you have to do some math. It's completely, how many pods you can put on a node depends on the size of the node, on the node type. AKS lets you choose between KubeNet, which is the default network plugin for Kubernetes, and it does some magic routing on the back to make it VXLAN compatible. Or you can choose their Azure CNI. The Azure CNI is very similar to the AWS VPC CNI. It puts the pods directly on the same VPC network as the nodes. And so therefore, it also makes it more difficult to segregate your pod and your node traffic and the firewall rules that apply to them. GKE, QNet, they do magic. They are going to soon, right now it's an option, but they will start making their IP aliasing the default, which also puts the pods on the same VPC network. But in this case, it's probably, I'm not sure how they're going to manage the firewall rules, but overall it's a bit more secure, because this way they can prevent spoofing, they can do actual end-to-end checks. I talked about this. Okay, network policy support. Once again, EKS, you can use Calico, but you do have to install it manually and manage upgrades. For Azure, either of the two network choices support Calico. The Azure CNI also supports Azure policy. These are both implementations of the network policy API, so you can actually use the same manifest for either one. They behave the same. Calico is a nice addition, though. They have their own additional resources. Network policies apply at the namespace, so if you want to do some blanket network rules, let's say you want to block access to the kubelet port from all namespaces, you have to put a network policy in every single namespace, which is upkeep if you have a very dynamic cluster. Calico has a global network policy which can apply to your whole cluster. So if you have those rules that you want to apply to every namespace, that makes it a lot easier to manage. And GKE uses Calico, and you can enable network policy at any time. Azure, there's one thing about it also, and this is not the only case where this happens. If you do want network policy, you have to create the cluster. And Azure does this for a lot of features. And even as they add new features, some of them come up this way. So if you do use Azure, I suggest you just automate or have a process where when they release a new feature you want, you have a nice way just to move your workload, create a new cluster, move your workload over, and be happy. So standard Kubernetes security options. RBAC is the default for everything. It is always enabled on Elastic Kubernetes service. This is another one of those places where Azure you have to select RBAC when you create your cluster. Pod security policy is also always enabled in AWS, optional in the other three. Pod security policies are almost certainly going to be deprecated soon, but there's no standard replacement yet. So if you're using them, keep using them. If you're not using them, don't invest a huge amount of automation in it. They are nice to have to enforce best practices, but there are other ways to do it that are probably better investments. The Kubernetes API endpoint, by default, all three providers leave it open to the internet. This is bad. There's usually no reason that the entire internet needs to see your API endpoint, but more importantly, there have been some very important vulnerabilities, CVEs discovered against the endpoint, including late last year we saw the Billion Laughs attack, which allowed unauthenticated users to perform basically a denial of service attack against your API endpoint. So you really want to lock this down. Yeah, all three of the services offer some way of either making the API endpoint private only to your VPC, or for the public endpoint, providing a whitelist of IP addresses which are allowed to connect. And read-only root file systems on the nodes are really useful because if somebody somehow gets access to the node, whether it's through a compromised pod or some other way, this prevents them from either installing their own crypto miner or maybe overwriting a binary that root may run with something that does something else. So having a static file system is a much better protection. However, right now GKE is the only provider that supports this, and it's only for the container optimized OS. Service limits are kind of a mixed bag, and some of these are really confusing. I spent a lot of time digging through these. Max clusters is pretty straightforward. Amazon, you can do up to 100 in a region. A lot of these you can request increases. That one I believe you can request an increase. AKS is 100 clusters period for each. What do they call their organization? I think subscription. Yeah. Azure it's a subscription. AWS it's an account, and Google it's a project. Okay. GKE lets you have 50 per zone and a total of 50 regional clusters. There are a lot of zones, so you could actually have a lot of zonal clusters. Number of nodes per cluster. EKS, in a managed node group, you can have 1,000. I don't think there's a hard limit on self-managed because it's just a plain auto-scaling group. I'm not sure how many could successfully register with the master, though. AKS, it's 100 to 1,000. It depends on the VM type and some other variables around networking. GKE, it's 5,000, except if you're using their ingress controller. And Kubernetes officially supports 5,000, up to 5,000 nodes in a cluster. Nodes per node pool, it's kind of all over the place. GKE doesn't tell you how many node pools they support for a cluster, but the EKS and AKS, it's 10. Max pods per node. As I mentioned for EKS, it depends on your instance type. And it's also actually lower, much lower for Windows, if you're using Windows nodes, because they can only support one elastic network interface for whatever reason, although there can be multiple addresses on it. AKS, I have no idea that this range of numbers, I can't tell you which one, there's no clear logic or precedence. It will fall somewhere between 30 and 250. And GKE is 110. Kubernetes right now still recommends 100 pods per node. No more than. So I do have the takeaways here, and these are my official slides. There's some kind of a few other differentiators that I will go into that are not on the slides. So obviously there are a lot of differences between these providers. GKE is obviously is both from what we've seen, and if you dig into the features that are available and just the general impression of their security offerings, their default security stance, by far the most mature, which you'd expect and hope. The thing about version promotion is a little weird, but otherwise they also offer a lot of neat things. You can, if you have very sensitive workloads, you can put those you can sandbox them in gvisor to isolate your other workloads. They have, let's see, there are a bunch of nice add-ons, and I'm blanking on a lot of them. Oh, they will install Istio, the Istio service mesh for you, and do the upgrades. They won't configure it for you, and that is by far the most work, but they will install it and do upgrades for you. You can install Knative. It will do the same. It will manage upgrades, but they call it Cloud Run, but you'll still have to manage it, the configuration. Obviously, AKS and EKS require more hands-on. It's not as automated, or you can automate it yourself, but it's not automated by the cloud provider. And this is all based on a blog post I wrote last month, about a month ago, which you can read at www.stackrocks.com. There's a lot more information, but I'm going to go a little off the record here and talk about a few more things which are not really blogged or mentioned in the slides. Overall, I don't have any hands-on with Azure for protection. There are some network things that I wish they did better. The one thing my favorite thing about Azure, about AKS, they install the Kubernetes dashboard in every single cluster, and you can't delete it. And this becomes a security issue because the Kubernetes dashboard is not very multi-tenant friendly. So, to say the least. It is not open to the internet. It is a private service. However, that means any service, any workload within the cluster can also connect and have the same permissions, and there is no authentication on it. So there's no password protection, there's no token protection. So it's actually a serious issue. The only defense you have is to remove any RBAC permissions. And I just lost little things here. So that's probably the worst thing about Azure. Overall, most of these issues are manageable. You can, to some extent, with network policies, control some of your traffic. It is still difficult if you're using the Azure CNI to segregate pod and node traffic. In most cases, otherwise the differences between using KubeNet and Azure CNI. Azure CNI offloads a little of the overhead for networking, a little of the compute overhead, but it's not I haven't benchmarked it. It's probably not a huge difference. You're going to have to trade that off with the fact that it is harder to secure. EKS is... So let me preface this by saying that if you have access to any of my personal data, please don't put it in an EKS cluster. The management overhead aside, it is very difficult to secure. And if you watch the updates, Azure has gone all in on Kubernetes. They regularly, obviously they're farthest ahead in the versions that they are at least in preview supporting, and they're constantly adding features. And some of these features are, yes, integrations with other Azure services, but a lot of them are just nice new Kubernetes features as they come and get released. Interestingly, Azure and Amazon released their Kubernetes services in the same month, June 2018. Azure has made a lot of progress, and they were both extremely, obviously, something they wanted out the door quickly. Azure has made a lot of progress since then. Amazon, not very much. And even now, they're not really adding a lot of really operability or security-wise features to EKS. It's mostly, when you do see something come out, it's mostly integrations with other Amazon services rather than core Kubernetes offerings. It's a lot of work to really manage a secure EKS cluster. It's a lot of overhead for the user to do, both initially to set up and to operate over time. Hopefully, Amazon will step up and try to add some maturity to this product, but I haven't seen any sign of that. I would definitely reconsider if you have, and I realize a lot of people don't have a choice on which cloud provider they can use, but if you do have a choice, I would strongly recommend going to another provider. You do also have, if you are stuck on Amazon, and especially if you do have some resources, both skills and a little extra money, I would consider self-installing and managing something directly on EC2, whether it's COPS or kubeadm or OpenShift or something else. There are a lot of options that you can install and manage yourself. It'll give you, there's a little extra cost because you're going to have to, both financially because you have to run the masters yourself on EC2 instances, and there's a little more management overhead, but you do get a lot more control in return. So if you really want to secure it, you're stuck on AWS, I would strongly recommend considering that option. And if you have a good relationship with an AWS support or technical account manager, complain. Complain. They have the market share as a cloud provider, so I think a lot of people just default to trying EKS. It's like, oh, we have to do Kubernetes, but it's unfortunate that it's by far the least mature of the three offerings. So any questions?
Any thoughts on VMware going all in on Kubernetes and their cloud offerings?
VMware, do they don't have a cloud service yet, do they? Then I'm.
They team with Amazon, but they're changing their entire control plane in VMware to be Kubernetes.
Okay, yeah. The question is, what about VMware now changing? Is like the vSphere type? Okay, the vSphere, moving vSphere more towards Kubernetes. They're a little slow. I haven't looked at it personally, but I think that's showing. We've seen that kind of move in a lot of places. Like Azure, when they launched, they had their own container service. It's gone now because they said everyone's going in on Kubernetes. Amazon still has their own container service, and it's much older though. They have a larger customer base, but it gets active development. I watched their announcements, their release announcements. EKS gets new features every week or two, where EKS doesn't.
Have you looked at DigitalOcean at all?
I haven't looked at DigitalOcean. I would for VMware though. It's kind of interesting because, say for example, I know a lot of on-prem is also building on vSphere, on traditional vSphere, like Google Anthos requires right now. It only runs on vSphere. So it's both convergence and divergence. It's VMware is moving in the same direction, but So it's an interesting time if you're interested in how these versions kind of evolve. And it's almost the way, viruses kind of evolve to some degree. So. and spread, and then people get resistance, and yeah.
I mean, I actually have a question.
Okay.
So one of the things that's bothered me about all of these public cloud options is they all still require me to care about nodes. And if I'm going to use a public cloud dedicated Kubernetes service, the one thing I don't want to have to care about is nodes.
So,
is anyone moving towards, you know, so-called nodeless Kubernetes in any kind of meaningful way?
thank you for asking. So I used to have so right now, all right, AWS is one of their big announcements, one of their two big announcements for EKS at reInvent in December. Oh, hey, now you can use EKS on Fargate, so you can deploy EKS pods onto nodeless, which run on Fargate. Well, that's great, except for a lot of things. One thing is that you still need at least one node in your EKS cluster. Don't ask me why.
The second thing is there's a lot of restrictions on what kind of workloads they'll accept.
Exactly. Yes, exactly. The biggest restriction, and this is universal. So Azure also will let you do nodeless, and they use their container instances. And even though they're different implementations. Azure's is based on the open source virtual kubelet. Amazon's is some secret sauce, but they converge in what they allow you to do, interestingly. Daemon sets are not supported, so anything that you would normally want to run, usually monitoring or security or log metric collection or whatever, anything you would normally want to run on every node is not going to run. In most cases, you can convert this to a sidecar. It's not always useful. So it's useful if you want log collection or metrics collection. But let's say you're running Calico because network policy, because security. Calico, yeah, you could put it in a sidecar. However, the other common restriction is that you cannot run privileged workloads on the pods, on the nodeless pods. And there are obvious reasons why, because this is not only, Kubernetes is multi-tenant, but it's still all your resources. Fargate, Azure Container Instances, those are multi-customer, multi-tenant. So you don't know Joe Schmo, and you don't want Joe Schmo to have root on your machine, and he doesn't want you to have, So you can't, Calico has to change IP tables rules. That requires a privileged workload. They just silently fail. Even if the rest of your cluster has network policies, they just don't exist. They're ignored. They just, the nodes are, the pods on nodeless workloads just don't have network policies. Also means service meshes like Istio won't work because they also need to make modifications to the IP tables rules. So there are, even Amazon in their documentation for Fargate, EKS on Fargate, strongly recommends not putting sensitive workloads on these. And you also, if you really care about security and you're not just monitoring within the cluster, but you're monitoring the process calls, the actual network flows from the node kernel, you don't have that visibility. So these are, for some workloads, that's fine. For a lot of workloads, that's going to be a deal breaker. And I don't know that that's something that's going to change anytime soon just because of the technology, the way Kubernetes and nodeless does and doesn't work. GKE doesn't have a nodeless option. There are some, you can kind of fake it using something like Cloud Run, but it's not really the same thing.
So AKS has virtual nodes.
Yes, AKS, both AKS and EKS do support nodeless, where the workload is actually on their container service.
Okay, I have one more question, and I'm asking this because I'm part of SIG release in Kubernetes, which is, do you think the various clouds are stuck on 1.14 because they're just lagging a little, or because that was sort of the first production version they had, and they're going to be there forever?
I don't know. I don't think Azure will. Azure seems to, like I said, they seem to be going all in, and they have 1.16 and 1.17 in preview. Okay. You know this. 1.16 has a big. They're removing a lot of older versions of APIs, the deprecated versions, like the beta versions. So this is going to be both internally for their services and for a lot of customers potentially an issue. And Azure does weekly, almost weekly notices about their current state of Azure releases, and they've just been, every time they're saying, oh yes, with 1.16, that's a big deal. So I think they will be, all will be slower when they actually move to 1.16, because it can be breaking for a lot of workloads. I honestly don't know. I mean, in the case of, I've heard rumors why GKE has become so slow on promoting. I don't know if they're true or not. I've heard rumors about why EKS is not making any progress. They're probably true, but I can't really repeat them. I have no idea. But even the documentation right now says it should be a 3-month cadence. They all say that, and they don't always follow through.
Well, thank you.
Thank you.